Tim Keen from New Mexico, a friend of mine, K5DEZ, saw this article and decided to simplify it. And so he took this schematic right here and he simplified it to this schematic right here. And this is actually his handwriting. He drew it out for me and said, hey, you ought to try building this this Morse code paddle. And so that's his handwriting. And so that is the project. It's just a simplified version of the force sensing CW paddle in QST Magazine, February 2019. All right. He has posted on several websites his simplified version of the schematic. So anyway, so what we've done, we've neared the end here. And so I took the schematic and I took a bunch of components that are actually now soldered onto this board right here. And I put them in the breadboard and I tested it to make sure that it functioned properly. And it did. So then the next step we did was we started soldering, and we got about this far when I broke the other transistor I had. And the transistors that we were using the BS170s, but I only had 2 of them. And so since I broke that one, I had to move to the 2N7000s, which are also usable. So I just restarted on a different board, and I soldered in both of the 2N7000s into this board here. It's a very simple circuit. You've got basically just a 1 mega ohm resistor and actually 2 mega ohm resistors and 2 2N7000 transistors, and then a few little connections to round out the circuit. On the outside, I drilled holes in these the outside cover, and this is the pressure paddle right here, the pressure sensor, I should say. There's one on each side. This is going to be an enclosure. It's going to go closed. This is the 3.5 millimeter jack or pin that will go into that jack. And so that's where we ended up. So what I did was, I'll show you where we got to. So let me scoot this out of the way just a little bit. Let me pull this in. This is a CW hotline. It's just a little kit that has the ability for you to send Morse code directly over the internet without anything else. You can, if you have an internet connection, you don't need a computer, anything else, and you just connect this to somebody else's and can communicate with them. But that's not why I have this. It has also a keyer in it, and I use the keyer to test. And so I'm going to plug this in again and show you what the issue is, and then we're going to troubleshoot the issue, because we did run into an issue. We got everything soldered and we plugged it in and we got a problem. And by the way, just real quick, back to this is the transistor that I ruined by breaking that middle pin off. It's supposed to have 3 pins, so I don't even know why I'm keeping it. It's worthless. But all right, in we go. We'll plug the key or paddle in right there, and when I turn on the power, we get just how it should work is we should get silence when I turn this on. And only it should transmit when you push the paddles, one of these pressure points. But when I turn it on, we get that problem. So this is where we left off yesterday for this project. And I said that what we'll do is we'll go through the troubleshooting process today to figure out where I went wrong. Well, as it turns out, I was just thinking about it. I didn't even really look at the schematic or the circuit at all. I did kind of go through and make sure that all the connections were soldered correctly and that there were no short circuits anywhere in this, and there weren't. But other than that, I really didn't trace it or anything like that to kind of figure it out, because as it occurred to me that, let me grab a piece of paper here to show you what I was working on. So as I mentioned just a minute ago, this schematic, I started with the BS170, and I have the data sheet for the BS170 and the pinout right here, okay? And so then, as I mentioned, I broke that middle pin, and so we had to go to the 2N7000. We had to switch it up the circuit with just those transistors instead, because didn't have any more of the BS170s. Okay, so you'll notice the pinout right here. 1, 2, 3 going clockwise, DGS. So we've got the drain is pin 1, the gate is pin 2, and the source is pin 3. Okay. Well, then I went over to the internet for the new N7000, and I printed off the data sheet for that. And I was looking at it, and I'm like, oh, okay, look what we have here. We've got 1, 2, 3, and then I have the you know, the kind of the same schematic. So I made the assumption that you're gonna love this. I made the assumption that the BS170 pinout was the same as the N7000. Well, as it turns out, I went and looked again at that a little closer, and as you can see, the pinout for the N2N7000 is not the same. So I soldered the transistor in wrong. Look at this. Check it out. This is what you call a rookie mistake, and so the one on the left is the BS170. The one on the right is the 2N7000. So what this means is I have both of those transistors in backwards, and so I don't even need to trace or anything like that. Hey Wayne, it's not a transistor radio. I'm doing I'm building a Morse code paddle, pressure paddle with a pressure sensor on the outside. And so anyway, so the troubleshooting, I don't even need to go through and do any of the troubleshooting steps, because I firmly believe that I need to just switch out these transistors and turn them around. That's going to pose a problem though, because they're kind of in there good. But I think if I just switch out these transistors and turn them around, so it might have a problem with that though, because what's going to happen is, see this pad with with these metal on it. If you solder and desolder multiple times, a lot of times that'll come up off the board. The metal will. So we're taking a risk. We're going to do it though. I think what we're going to do as a course of action to correct this issue is we're going to take these two transistors out and turn them around and resolder them to this board, and then we're going to run a test and see how it goes. You know what? It may work and it may not work. And if it does work, good. We will go with it. If it does not work, then we will just build another one. I mean, I have 2 more of these right here. 2 more of these boards, so we can try it again. And also I ordered a bunch more of the, these are the Fairchild. It doesn't really say on the box, on this bag, but what they are the 2N7000s. There's a bunch here because all I could find was 2 of the 2N7000, so I'm out of transistors, so I had to order some more. So anyway, let's do that. Let's go ahead and get this on someplace where I can desolder it with all these parts and stuff like that. All these other stuff soldered to it. It's going to be a challenge, but we are going to give it a try. That shouldn't take too long. But let's see if we can put it on here and figure it out. I'm going to move these over here, these over here. All right. I better turn on my soldering iron right now so it can heat up. Let's see. All right, there, like that. It's just kind of going to sit there precariously, and we're going to try to do our best with it, with all these other wires and stuff. Like I said, we will give it a try and see what happens. All right, so we're going to take this transistor. The flat part is facing me. I'm going to desolder these, or what we're going to do is just touch the soldering iron to these. And let me move in here just a little closer. We're going to take the soldering iron to these 3 pins up here and try to pull this out, turn it around so that the flat part faces that way, and then hopefully try to be able to push it back up through and get it resoldered in. Then we'll do the same with this one. As I said, though, the problem is with these boards is if you solder, you can solder a little bit, but if you resolder and then if I solder a component to it, then desolder it and then try to resolder it, a lot of times the metal on this board will come off, and then if that comes off, then we're just it's kind of ruined and we got to move on. Well, let's undertake it. Let's go ahead and do it and see if we can make it happen. And if we can, then I will be a happy camper. We'll move forward with it. And then there's a few other things we got to do to close up the enclosure, but we'll get there. Let's do this first. We've got to have a functioning circuit first. So let me tin this, turn the fan on. All right. Hold on. It's got to be in there a little better. I'm going to try to get that to stick a little better. There we go. Sorry for the hand covering. There we go. Okay, so here we go. Yes. All right. Now the hard part. It's easy pulling it out, but it's not so easy getting it back through. For a couple reasons. One is you got to get it to through the right holes. Let me see here. All right. Let me see something. Maybe this will help better. There we go. All right, so it looks like that pin is right next to there. I'm just trying to make sure I get this right. I don't want to redo it. Okay. So we're going to want those pins in. Such a tight fit. I think that's it. Let's see. Let me zoom out here, or zoom back in. All right, guys. So we have this. So they're trying to get that back in. Has a little gloop on it. Maybe if I can remove some of that. Got to be careful too, because you don't want to overheat this transistor too much, because it'll ruin the transistor. So, all these dangers. All right, I got that off though. All right, in we go. I'm going to try to straighten these just a little bit. Okay. Turn the fan off for just a minute. Bring the light down a little bit more. It's such delicate and exact work to get these to go, but I think I have that. Let me hold it in like that and try to bring the soldering iron back over and push it through. There's one, and there's one. It's not going through for some reason. This is really hard. Yeah, it fell out. All right. I might need to just remove the solder on that side if I can. It's just a gloop there, 3 gloops, but let's try it one more time. Get all this stuff out of the way if I can. There we are. It's just not going in. That one, and that one. All right. Let's try again. Aha! Success! All right. So we've got a mess now to clean up, but at least they're through. And it looks fine. Okay. Okay, good. All right, so not too bad of a mess either. It just looks like this one. Let me get something to point with. So we've got this one right here. It's got a hole. We need to fill that in still. These seem to be fine. This one and this one. But this one right here, I need to add just a little bit of solder, or at least at the very least, move the solder over that hole. You can see it really good right there. That right there. We need to fill that in. Okay, what I'm going to do is I'm going to take these and trim them in a minute, but not right now. Let's go ahead and finish that up. And we'll do the other side, and then we'll put it on the keyer again and hope for the best. Okay, fan on. That might have did it. Let's see. Yep, there we go. Okay, so I was just showing you every time what I do. I guess I'll do it this time, but not every time do I do this. Just kind of show you. Got the old garbage can down there, and I'm just going to trim those leads off because they came through further than when they were in there before. Keep bumping it. Sorry, guys. I think that's just going to be it right there. All right, back up to the project. Scoot the garbage can out of the way. All right, half done with the correction on this. Now, let me just pause real quick. If you guys are just here, just a couple things I need to mention because some of you may have showed up late. So I'm gonna redo this. Sorry, guys who have been here the whole time, but I wanted to be sure and let everybody know. So first thing is, this is a Morse code paddle. Here's the schematic, and it's based off of an article in the QST Magazine. The article name is A Force Sensing CW Paddle, and it's from February 2019, okay? This is not the paddle I'm trying to make. What ends up happening is my friend, Tim Keen K5DEZ, saw this article and came up with a simplified version, which is this, and this is his drawing of it, and it's what I'm following, okay? So then we went through the whole process. I explained to get to this point, and it wasn't working. I demonstrated that just a few minutes ago, how it wasn't working. I realized that the pinout was wrong, and so let me show you that, and then we'll move on. So this is the pinout for the transistor we were using before, and then I had to switch to a different transistor because I broke one of them, and I needed a new pair. So we went to this transistor, and as you can see, I assumed that the pinouts were the same, but they are not. And so what I'm doing is I'm switching out I soldered these in based on the other transistor pinout, but this is not correct. So what I'm doing now is I'm going to desolder this other one and turn it around, and then we'll be done here. And then we'll plug it in, and maybe it'll work, and maybe it still won't. We'll see. So let me get this back on the, I don't even know what you call this thing. It's just a grabber of some sort. But we'll desolder this side and turn it around and do the same thing, and then we'll be able to turn the battery on and put it into the Morse code keyer, and we will see if we get success. Again, this is the easy part, removing them. Come on, get out of there. Come on, get out. Why aren't you coming? Boy, that heated up a lot. I better give that a time to cool down. For some reason, that didn't come out quite as easy. Let's try it again now. There we go. Got it out. Whew, that burned up a lot. That's really hot. I hope I didn't ruin that transistor. That thing warmed up. I could feel it in my finger. But there's not a lot of, oh, there's a little gloop on that one right there that'll pose a problem with me putting it back in unless I get it off. So let me do that real quick. Okay. All right, good to go. So we're turning this one around now too. So the flat part should face me on this one. And we'll try to stick it back in there. It wasn't easy on the last one. I don't expect it'll be easy on this one. Right there. Come on. My fingers are too big. All right, let's see. Come on. Got to make sure those are in the holes, and I think they are now, right like that. We shall see. Okay, that is good. Let's take a close look at that. All right. I am crossing my fingers, guys. Let's hope this works. Okay, let's move this out of the way and plug it back in. Get this over here. Plug it in. Is that off? Yep, that's off. What we're looking for here is we don't want to hear anything when I turn the power on. We want silence. And if we get silence, then that's encouraging. Here we go. Oh, yes. Now, let's test one of these pads. Nothing. All right. How about this side? You know what that tells me? That this resistor on this side may have gotten burnt out when I resoldered it. But we've got the dits, but not the DAWs. All right. Well, let's see what else we can do here. Take a closer look at this. Let's see, is that this side? Yeah. This is the side that is not working. Oh, look at that. It's a solder bridge right there. Oops. You see it? Solder bridge. Trouble. All right, let's see if I can fix that. If I can, then that may solve the problem. Let me just show you a point to it for those of you who may not know what a solder bridge is. It's when you accidentally solder, you know, these should be separate. So like if I soldered something in this pin and then I soldered something in this pin, we don't want solder across the two. That's not meant, because there's not supposed to be a connection across there, just along these pads. Well, look right here. You see that? That right there is a solder bridge. And that happened when I pushed the pins back through on that transistor. And so I need to figure out a way to get that removed, that bridge right there. So, what do we do? Let me unplug and get this out of the way. And I'll put this back on here, and we will try to get that separated. That's going to be a tall order, but we will try to figure it out. Let's just start by seeing if we can run this through. And if we can't, then we will have to get some copper braiding and remove. So it's still there. I might have to get some copper braiding and remove that solder. Let's see. Let's try it one more time here. Is it right? Where is it? Right there. Oh, is that side too? Looks like it's just a mess. Let me get the copper braiding. There's no way I'm going to be able to get that solved. There's just too much solder on there. And for those of you who don't know, copper braiding is a way to grab solder back off of a circuit board. And I will tell you that we've already resoldered on this board several times, and I'm worried that we are reaching our limit. But like I said before, if we reach our limit, we will just go ahead and make another board. All right. Let's take another look at that now. Well, what do you know? That looks clean. Let's plug it in. So here's a look at what the copper braiding looks like. Just this braid here, and then you just lay it over the top and heat it up, and it just has a way of kind of a wicking. It just kind of wicks into this and pulls solder off of the board here. So, all right. Once again, let's get this CW hotline plugged in and powered up and hope that that paddle works now. It just, okay, powered up. Plug it in, and there we go. All right, we have a functioning paddle now. So it should come together eventually like this. Okay, and I will be in the field sending like this. Let me do it on this side. I'm left-handed, so. And I like this on this side. Here we go. Ready? This is what it's going to be like. All right, we did it. Okay, so we have a functioning circuit now. I'm very happy about that because I was worried we were going to have to really dig into that circuit and figure it out, but it is a very simple circuit. So, okay, so next steps here then are we're going to have to try to figure out how to get all this into this into this enclosure. All these, we have the wires running through. The problem I'm going to run into now is, as somebody last time, I think yesterday, mentioned, these leads are probably not long enough to get this in and working properly. Maybe if I turn it this way, it might work, but I wanted the battery to not come out the back. Let's see here. Anyway, the issue is these leads right here, I don't think are going to be long enough. So I'll take suggestions. Do we desolder from the board, or do we just clip it and then add some wire on either end? That's a good one to ask you guys, since some of you, I think, maybe are more experienced than I. So let's see. I think that is going to go there. Should I adhese it right now? Should I attach it? Maybe I should. I'm not sure. I'm kind of nervous too, because once we start moving things around, it could rip off and then it would be worse. But oh, let's see. And then there's this one. Okay. I'm going to try and figure this out. Maybe there's a way to add them. There is not going to be a way. Let's get this through. Cut and add wire to the middle, then slide on connects. Yeah, okay. That sounds like a good one. Temp tape. I'm not sure what that means exactly, but I'm sure it's a good help if I probably understood it. That way you can replace it easier later if needed. Yes, okay. Good idea. I think that's what we need to do. Yeah, don't you think, guys? We need to, it's just not going to work. I don't have enough lead here on this one. This one's going to be fine on this side. See if I can get this to press down. We're good on this side. Painter's tape over the sensor. Oh, yes. Very good recommendation. I appreciate it. To mock the fitting, yes. Okay, so here we go. Let's see. So this is, we want that there. I'm going to painter's tape it like you said. Let's do it. I love that suggestion. Thank you. So I have some right here. I'm just going to do it right there. It doesn't really matter if it's over the sensor or not. All right. And then this one, okay. Well, maybe. Look at that. Let me get this through. Got tape on that side. If I let go of this, it's gonna go, but let me just get some tape here. There we go. I think this is gonna be fine like this. Okay, so strain relief. What do we do for strain relief? Do we just be careful, or do we need to do something with strain relief with this? Maybe put some hot glue in this end? Or any suggestions on that, or just go with it? Just put it in there and be careful. Yeah. It's kind of loose. I think I should probably, I'm going to actually wrap tape all the way around this for now, because I'm not a ham, but still interested in learning Morse code, because CW with QRP power, that go longer distance. Yes, absolutely. I love Morse code. It's especially I do QRP as well, and it's great. So a small zip tie around the wire. Okay, good idea. Let me see if I can find one of those. I think I have a small zip tie that would fit in there. I'm gonna just do this for now, so that I don't lose this how it's connected. Because it's just kind of, it's hard for me to hold on to that. Okay, there we go. Good. All right. So I'm going to look for a zip tie. Let's see, where would I find one? Now this is going to be interesting. I'm going to take you guys on a journey through all of my bins and boxes, huh? Aha! Well, what do you know? Here they are. They're small. They should work. I'll have to clip off most of it, but good idea to just kind of wrap it around the end there and keep it secure. Electrical tape around the wire, hot glue to keep it in place. That way you have cut protection on the installation cover. Okay, good idea as well. Okay, let me put this back on. We're gonna move this back into here and get this twist tie. Looks like my friend Brian is, oh, guess what time it is? It's 12 noon here. It's time for the CWT, the high-speed Morse code contest. I don't think I'm going to do that today. Around the wire, then hot glue to keep it in place. Yeah. That's another idea. I'm going to try this though first and see how that does. If it doesn't work, then we'll try the hot glue way. I don't even know where my wife keeps her hot glue gun, but we will see if this works. Zip it tighter. Oh, I think that's going to work. Let me get it just a little, one more there, and then okay. Boom. All right. Good. Good deal. Now this, I think I can just tuck this in. It's on right now. I think this will just tuck right in there. Let me maybe do it this way. Yep. The other end. I'm going to use heat shrink around the enclosure. Right now we'll just leave the tape, but eventually we're going to use heat shrink to get this to work. So let me pop that on. We can pop it back off in a minute. Okay. I can actually remove some of this tape right here over that paddle. Okay, guys, we're gonna run a test on it again, and then I'm gonna say I need to locate the heat shrink, and I might not have the right stuff. I have to order it, but really, here it is. We're good to go. Looks nice. I'll add these adhesives here in a minute, but we got some good strain relief there. I think this wire is a little too short, but that's okay. We'll maybe make an extension for it or something. Let's scoot this stuff over and make room once again for the CW hotline. Plug it in, power it up. All right, well, I think that's going to do it for me. So we have here the Homebrew Morse code CW paddle, and it's a pressure paddle, and that project is done. So the last thing I'm going to do, I don't even need to show you guys, I'm going to put heat shrink over where the tape is, and then I'm going to take off the adhesive off the back side of these paddles, and we'll call it good. So that project's done. I don't need to show you that last little bit we're going to do. And I'm just going to leave it like that, guys. Believe it or not, I'm not going to go in and do anything else special with it. And the reason is because this is just a fun project. It was just kind of for fun. This isn't going to be my primary paddle forever. I'm just going to use it until it can't use it anymore, and then we're good. All right, everybody. So here is the final product. You can see I put heat shrink on there, and got these stuck to the outside of the enclosure. And so I want to thank everybody for joining me for this project. It was a really fun one. This paddle I put to use recently out in the field, and if you are interested in following along on that video and seeing how it went, I'll put it right up here. You just I guess right in here is where it will be posted, so you can just click on that link and it'll take you there, and you can see more about this paddle and how I used it in the field. With that, I'll say 73 everybody, and thank you so much for joining me.